Okay, let's connect some algebra to some geometry. Okay, so if we want to find the perimeter of a triangle with vertices this and so, and then wonder if it's a right triangle, how do I do that? Yeah, that's a good idea, right? I just tried to draw a picture. Okay, so here's a place, right? I want to draw a picture of these things in that. How do I do that? Okay, so let's assume that this is a xy plane, right? And we'll assume that these are xy pairs, although the names are not particularly important, right? So let's see, if I go, what's a -3, -1 look like on the picture?
To the left, 1 down.
Okay, so we go 1, 2, 3, 1 down. Okay, so there's my point, -3, -1. Okay, what else have I got?
For the right, 4 down.
Okay, 1, 2, 3, 4, 2, 3, 4. That's down here. 4 -4. Okay, then what?
1 to the left, 1 up.
1 left, 1 up. Okay. So my triangle, ooh, it's not every day you could use a stick. Okay, so my triangle looks like this, right? Let's do black side. Red side. Whoops. It's not every day you get to use a meter stick. Some days you just aren't going to do a good job. Okay, red side and see if we can get the blue side now. Oh. Went all wobbly. Okay, so anyway, you guys got the idea, right? So from eyeballing this, does it look like this is probably a right triangle?
No, not.
Probably not.
Yeah.
That's just
How would I check? Yeah, we could try the Pythagorean Theorem, right? So to try the Pythagorean Theorem, I would need to know the lengths of the sides. Okay, so I might put that off for a minute. What else are they asking for? The perimeter? Oh.
So you really need to know the length of the sides.
I really need to know the lengths of the sides anyway. Okay, so bummer, I have to do that. All right, so let's do that. So how long is, say, I don't know, which side do you want to start with? Black side?
Black side, because we
Okay.
are diverse.
So B for black side
Yes, yes, yes.
is how big? I want to know
No,
2.
this length, right? Is it 2?
Think so.
Uh-uh. Uh-uh.
Let's see.
So don't measure off the picture.
Isn't it?
Why aren't you measuring off the picture?
Because this isn't to scale. and
Yeah, because
go
this was
back.
a really crummy picture, right? If I had done a better job, then I could try to measure off the picture. But if I want an
Everything
exact
is
answer,
measured out exactly.
And like it's like the x2
yeah, I should use the distance formula, right? So the distance formula tells me about the length of side B, right?
Yeah.
So B is the square root of what?
-3 minus 1 squared and -1 minus, -3 plus 1 squared, -1.
Okay, so we're doing the difference in the x's, right? So the x's are -3 minus -1, right? Difference in the x's. And then what's the other thing we have here?
Minus 1, minus 1.
So we do -1 minus 1, right? That's the difference in the y's. Make sure you're doing them in the same order, right? Guys cool with that? That's really not for this. This thing doesn't care about the order so much as long as you get the x's together, the y's together, and do a difference. The thing that I want you to keep the points straight in is lines. And just because we're doing this, we might do lines at the same time. We should keep things together. All right, so let's see. I've got the square root of, what's this stuff?
4.
Negative 2 squared.
Negative 2 squared plus, what's this stuff?
Negative 2 squared.
Also negative 2 squared. So I get,
4.
why don't you get minus 4?
Because negative 2 times negative 2 is positive 4.
Good. So you get 4 plus 4, which is the square root of
8.
Which is
8.
2 root 2.
which is 2 root 2's. You guys see that? You guys go on? Where is the, this is the Pythagorean Theorem though, right? You guys see that?
Yeah.
Do you see the triangle I'm doing it to? I'm doing it to this triangle.
Yeah.
Okay, so now if we want, what's up, Josh?
Question about the test. Is there going to be any vocab on it, like last time?
It's possible.
Okay.
Not an extremely large amount.
This last time was like a small amount.
Yeah, I wouldn't expect more than last time by any means.
All right.
All right, let's see. So blue side.
I'd say use this bottle, but get this go.
Can I get an answer for the blue side?
Square root of negative 3 minus 4 squared plus negative 1 minus negative 4 squared.
Like this?
Yes.
So let's see, that's the x minus the other x squared, then added to the y minus the other y squared, and then squared the whole thing. Cool. All right, so what do I get in here?
49 plus 9.
Negative 7 squared.
Okay, so I've got negative 7 squared plus,
3.
yeah, negative 1 plus 3 is, or negative 1 plus 4 is 3 squared. So I get the
49
square
plus
root
9.
of 49 plus 9 is
58.
58. Yucky number, right?
Yeah.
But it's a number. Okay.
Kill the fire.
All right, so let's see. How about the red side?
Negative 1 minus 4 squared plus 1 minus negative 4 squared.
Okay. The x minus the x squared plus the y minus the other y. Did I just do that one? That one feels like I just did that one.
No, we didn't do that. But close.
Take one number.
So what's the difference? Why does it feel like I just did that one?
Because it's the same except for the first x.
Yeah.
Because
One's
you're
in
using
fours.
the same points for everything.
Yeah, I keep using points, right? I've got 3 sides. There's 3 points, so each side's going to include a
Yeah.
point you used for something else, right?
Yeah.
So this one ends in the same spot, right? That's why it feels like I'm doing the same thing. So what do I get out of this?
25 plus 25.
Oh. So I get the square root of 50.
Which is 5 root
Which is 5 root 2. Cool.
2. The mass of all of them something.
Yeah, it would be nice if they were all more convenient, but they're not. Okay, so I got this. What's the perimeter? I was supposed to find a perimeter, right?
2 root 2 plus 5 root 2 plus the square root of 58.
So remembering, right, that they asked me kind of a sentence, I should answer with kind of a sentence. So maybe I should answer with a real sentence, like the perimeter, right, is,
7 root 2 plus the square root of 58.
let's see, there's a 2 root 2's, 5 more is 7 root 2's plus the square root of 58. You see that? Can I do anything with the square root of 58?
You could put it down to 2 square roots of 14.5, but I don't think you want
Probably not.
Yeah.
Right, so I could think, all right, 58 is 2 times 29. Is 29?
It would be, 58 would be 7.61.
So it would be approximately, right? But if I'm not willing to go approximately, then I can't fix the square root of 29, right?
No, you cannot.
So the best I could do is maybe factor a square root of 2 out of everything here, which is not really doing much. So I wouldn't worry about this. I would say that's the perimeter, right? And then answering the second question, is it a right triangle?
Nope.
How do you check?
You have to make sure there are 2 sides.
You square 2 sides, add them together, and see if they equal the third side squared.
Yeah, what should the third side squared be? Do I have to try that with all the arrangements? You guys see that? Really, I'm just going to check the Pythagorean theorem. So I'm going to take 2 sides. I'm going to do a squared plus b squared and check if that's c squared, right? But do I have to do that for all the sides? Why not? Yeah, but what? There's different choices, right, for a, b, and c. So why don't I have to do them all?
The longest one's C.
Yeah, the long one's going to be c, right? So I've got here the square root of 8, the square root of 58, and the square root of 50, right? Which of those is the big one?
58.
Square root of 58 is the big one, right? So I'm wondering, all right, this is going to be c. Is this squared? Does it matter about these two?
No.
No, this thing's symmetrical in those two, right? So is the square root of 8 squared plus the square root of 50 squared? Is that the square root of 58 squared?
That's 50.
Don't panic, man. What's 8 square root squared? 8.
Plus 50.
What's 50 square root squared?
50.
50. What's 58 square root squared? So is 8 plus 50? Is that 58?
I don't think it is. I think it's a trick right there.
Seems like it is.
Yeah, it's a trick.
So where's the right angle in this picture?
It's supposed to be between the black and blue. Or no.
It's supposed to be between black and which?
Red.
So on a right triangle, the long side goes across from
The right angle.
the right angle. So which one was the long side?
Black and red.
Black and red were the short sides, right? Blue is the long side.
Yeah, so black and red.
Yeah, so that right angle should be here.
Can we give them numbers?
You guys see that? So what happened to my picture? Why did this look so dorky?
Because you measured it out.
So they're
Yeah, because I hand drew it out, and this one unit is a little bit short. You guys see that? I did 3 units this way, and it's more like 2.5 on the picture.
And actually, each one of them going to the left is a little bit shorter.
You guys see that? Really, I screwed up my picture, and I can even see where it screwed up. It's a little bit compressed that way. If I pulled it out a little bit, it would be obvious that it was a right angle.
It's like you put it into a trash compressor and you're like, hey, I don't care about this anymore. Crush it.
That's exactly what it's like.
It's kind of like that, yes. Except I only crushed this part. I left all that stuff
Well,
out.
yeah, you had a shortage in your circuit, so it didn't work.
You guys cool with this? So the answer is, the perimeter is this, and what else?
Yes, there's a right triangle.
Because
Science.
cool? Yes, it is. All right.